In this session, we are going to see how to evaluate a definite integral by substitution. In the previous session, we have already seen different types of indefinite integral, how to apply, and how we are going to go out with different forms or some specific indefinite integrals as well. Now, in this part, we are going to specifically look into the substitution part of definite integral. Now, what is this definite integral? We have already seen in the previous part the definite integral is that particular integration where we have got the limits from a to b, or it might be from 0 to 1, or it might be from 0 to pi by 2. Now let's try to understand this substitution part for definite integral. Now in this case, you can see here that integration by substitution is one of the most important method. Why? Because if you're not going to take the help of substitution, the problem will be more lengthy and it will be more time consuming, as well as it will be more confusing. So in order to get rid of those confusion and in order to get rid of the time, in order to reduce the time, we are going to use a beautiful method called as substitution. So now in this case, what are the things we are going to look into it? Let's try to understand few main points. First thing is transform the integrals. Yes, you have to transform the integrals. Now you are going to see that it is not in any standard form. You are going to convert that integral into some of the standard forms which we have already discussed in the earlier sessions. So you are going to convert that into a normal form or the standard form by using a substitution. So you can replace a particular integral part with other form so as to bring it down or breaking it down to a standard form. The next one, integration without constant. Yes, as we were saying here, definite integral, since we have got the limits from a to b or any different limits here, we are going to say that we are not going to have constants. But in some cases, we might be even asked to find out the integration using substitution for an indefinite integral. At that time also, whenever we are going to apply, we can ignore the constants. If it is there, still we can ignore the constant and we can add the constants as last. Next, substitute. Once you have already taken out the values, once you have substituted the value from one part to the other, you have to revamp the expression and you have to put it back into the original one. Next is not only the expression, you have to evaluate the integral limits as well. This is one of the most important thing. Majority of the students, what they will do is they will substitute, they will evaluate, they'll express, and they'll put it back into the original equation. But at the same time, many of the students, they will forget to evaluate the integral limits. Yes, of course, as you are going to revamp the equation, you have to revamp the integral limits. You have to write down the new integral limits. So that is nothing but determining the range limits and substitute the equation. This is what you need to understand. So transform the integrals, integration with constants, substitute and express. Next, evaluate the integral limits and give the definite range and answer the question. This is what you need to do, and it's one of the simplest one and the most important. I'm stressing on this word. It's a most important one whenever we are not going to get any question which is not in a standard form. So now let's have a look into this. Evaluate the definite integral with the limits 0 to 1 tan inverse x over 1 plus x square dx. Now if you're going to look into this, now I can directly say it is not in a standard form. So what we are going to do is we will convert this tan inverse x, or we will substitute this tan inverse x as some other term. You can take it as u, you can take it as t, you can take it as y, you can take it any other term other than x, because x is already there. Now in this case, we have taken tan inverse x equals to t. Now this has become t. Now if you have taken this is equals to t, now it's your duty to take the differentiation of it, because we have dx as well. So differentiation of tan inverse x is 1 by 1 plus x square dx, and equals to differentiation of t is dt. So now you can see here 1 by 1 plus x square dx is equals to dt. So it means this whole thing becomes dt. Now you can see the whole given point has been expressed into different form. Now at the same time, you have to see the limits has to be revamped. We need to write down the new limits. So now when x is equals to 1 and x equals to 0, what happens? When x equals to 1, I can say tan inverse 1 is pi by 4. So I can say t equals to pi by 4. Next, when x equals to 0, tan inverse 0 is 0, I can write t equals to 0. Now, if I'm going to substitute these values into this limits further, I can say the 0 to 1 has become 0 to pi by 4. I can write down the limits as integral 0 to pi by 4, and tan inverse x has become t, 1 by 1 plus x square dx has become dt. So it becomes t dt, very simple integration part. Very simple integration. Now we have got integral of t dt. Now what is integral of t dt? Integral of t dt is nothing but t square by 2. So now if I'm going to take it out, t square by 2 ranging from, the range is pi by 4 to 0. Now if I'm going to take it as t square by 2, I can write it as pi square by 4 square divided by 2, which I can write it as multiplied by half, and another one is 0 square by 2, which is going to be 0. So I can take it as pi square over 32 as the final answer. So now you can see here, the one which was a bit complex, we have converted into very simplest integration part. This is the beauty of integration by substitution. Okay, now I'm going to give you a very important tip here. Try to understand this and always try to apply it here. You can see whenever we are going to get any integration. Now here in this case, I have taken indefinite integral, but it applies for a definite as well as indefinite one. So first start with the given question. Now in this question, it's your duty to understand which one we have to substitute. So in this case, you can see cos of x square. So now you can see x square is being taken inside a cos. So it will be very difficult for us to integrate it normally. So you substitute that x square as u. Now if you're going to substitute x square as u, now the next job is compute du. That is nothing but differentiate. So you can say du equals to 2x dx. Now you can take this whole thing as du, this thing as u. Now this is going to simplify it here. So now if there is any limit for a definite integral, one extra thing will be there, that is limit. If there is a limit, find the new limits. That is nothing but if exists. If there is no limit, ignore it. Now do the replacement. Now in this case, we have to do the replacement here. Cos of x square is nothing but u. I can write it as cos u, and 2x dx is nothing but du. I can just write it here. So now, since it is an indefinite integral, you're going to add plus c. If it is a definite integral, you're going to add the limits, not the constant. Now, if you're going to substitute it back, integral of cos u is sine u. So after that, we have to substitute back to the original one. What is u here? U is nothing but x square. I can write sine of x square plus c. This will be our final answer. So this is how, by using a very simple method of substitution, we can convert a complex integration into a simplest one. Now let's try going on with one or two questions. Find the definite integral of 0 to pi by 2 sine x over 1 plus cos x dx. Now I'll rewrite the question here. 0 to pi by 2 and sine x over 1 plus cos x dx. Now if you're going to look into this, it's not in a standard form. So now you can see in the denominator we have 1 plus cos x, and if I'm going to differentiate it, the differentiation becomes sine x. So it's the best way to substitute. So what I will do is I'll take out u equals to 1 plus cos x. That's the first thing, identifying the substitution. So now once after identifying the substitution, the second step is finding out the differentiation or finding out du. Now it's not exactly du. If you have taken t equals to 1 plus cos x, you're going to find out dt. It's nothing but finding out the differentiation. So now I can take du equals to negative sine x dx. Now if you're going to observe this, 1 plus cos x, I have taken it as u, and you can see sine x dx has become du. The next important point is creating a new limit. So now when x is equals to 0 to pi by 2, I can take out u equals to, it is 1 plus cos x, 1 plus cos 0 is 1, 1 plus 1 becomes 2, and it becomes pi by 2. Cos of pi by 2 is 0, 0 plus 1 becomes 1. So now the new limit is u from 2 to 1. Now I'll substitute it back. Now I'll create a new integration by putting into the original one. So I can take 0 to pi by 2 becomes 2 to 1, and sin x dx is going to be negative du over 1 plus cos x is u. Now since we have a negative inside our integration, I can replace it by changing the limits, by interchanging the limits. I can take it as 1 to 2, 1 by u du, and 1 by u is a very simple standard integration, which is nothing but log u, or I can say ln u. So now if I'm going to take it as ln u here, and the range, mentioning the range is also important, is from 2 to 1, I can get the answer as ln 2 minus ln 1. Ln 1 is already equals to 0. I can say it as ln 2 as the final answer, which is nothing but our option C. So now look here how we have solved this equation or integration into a simplest form with the help of a substitution. Now let's try looking into one more question here. This question, you can see it's been taken from a paper 1 set 1 of 2019, and it is given for 2 marks. So now let's try to solve this by the help of substitution itself. Integration of 6 square x over root of tan square x plus 4 dx. Now we might have already seen in the previous one where we have got some specific integrations where we have got it as 1 over root of x square plus a square. That is the general format. But here instead of x we have got tan square. So our first point in understanding this is we will take it out tan x as u. So now if I'm going to take tan x as u, the next step is finding out du. So I can take differentiation of tan x is nothing but 6 square x. I'll take 6 square x dx equals to du. Now we can see here this is being taken out. 6 square x dx has been taken as du, and this particular part has been taken as u square. So now if you're going to rewrite the equation, you can take it as 6 square x dx, which is nothing but du. I can write it as 1 over root of u square plus 4 du. Now this is a standard form. Now what is the standard form? It is the standard form of log of a plus root of a whole denominator. Now what is that a? A is that particular variable which is present. Okay, so now if I'm going to take this out, I can write it as log of u plus root of the same thing which is there in the denominator, which is u square plus 4. It's basically u square plus 2 square. And now since we don't have any limits here, I'm going to add plus c to it. So now at last we have to substitute it back. So what is the value of u? U is nothing but tan x. I can write it as log of tan x plus root of tan square x plus 4 plus c will be our final answer, and which will give us 2 marks.